Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala rasulil kareem. Dear students, our next chapter is organic chemistry. We will discuss some basic topics like definition of organic chemistry, chemical diversity and magnitude of organic compounds, general characteristics of organic compounds, and homologous series. So we'll discuss first the basic definition of organic chemistry. The study of carbon containing compounds and their properties is called organic chemistry. पहले पहले स्टार्ट में डेफिनेशन ये की गई थी कि वो कंपाउंड्स जिनमें कार्बन होता है उसको हम ऑर्गेनिक कंपाउंड्स कहते हैं और ऑर्गेनिक कंपाउंड्स की स्टडी हम ऑर्गेनिक केमिस्ट्री में करते हैं. But few compounds such as carbon dioxide, carbon monoxide, not carbonated, carbonates and carbides are considered to be inorganic substances. So the new definition after detailed study of organic compounds, detailed study of structures of organic compounds, the chemist proposed new definition of organic chemistry that the study of hydrocarbons and their derivatives is called organic chemistry. Organic compounds वो कंपाउंड्स हैं जिनमें कार्बन के साथ साथ हाइड्रोजन भी अवेलेबल है. हाइड्रोजन इज another most important element in the organic compounds. So hydrocarbons and derivatives mean just like this is hydrocarbon replace this hydrogen with another atom like halogens, fluorine, chlorine, etc., or oxygen, OH. So these are derivatives. So organic compounds are such hydrocarbons and their derivatives, and study of such hydrocarbons and their derivatives is known as organic chemistry. You have to search the role of organic chemistry in our daily life. Okay, chemical diversity and magnitude of organic compounds. Meaning of this topic is that there are millions of organic compounds in our daily life. There are most हजारों करोड़ों अरबों ऑर्गेनिक कंपाउंड्स पाए जाते हैं नेचर में. इनकी कुछ खसूसियात हैं. There are few reasons of such vast diversity and large number of organic compounds. There are few reasons. The first reason is catenation. The self-linking ability of carbon is called catenation. हाइड्रोकार्बन्स करोड़ों तादाद में इसलिए पाए जाते हैं क्योंकि कार्बन catenation की प्रॉपर्टी शो करता है. Catenation means that carbon has the ability to attach, to bond, to link with itself in the very long chain. It can also form a branched chain. It can also form ring structures. It is the very unique property of carbon that it can link with each other to form long chain, to form branched chain, to form a ring closed chain. So that's why, due to this very good property, catenation, there are very large number of organic compounds. The next property due to which organic compounds exist in very large number in nature is isomerism. The compounds that have same molecular formula but different arrangement of atoms in their molecules are called isomers, and this phenomenon is known as isomerism. यानी compounds having same molecular formula like butane exist in the form of two structures. The formula of butane is C4H10. It can exist in straight chain as well as in branched chain. The number of carbon atoms in both structures are 4 and the number of hydrogen atoms in both structures are 4, but they differ in just structure. Their molecular formulas are same. This one is continuous chain, this one is branched chain. Such different compounds uh, that differs only in structure formula are known as isomers, and this property is known as isomerism. So due to isomerism, there are very large number of almost millions of organic compounds. Similarly, another example is that of pentane. Pentane, the molecular formula of pentane is C5H12. In all the three structures of pentane, carbon number is 5 and hydrogens are 12, but they are different in their structures. Their arrangement of atoms are different. So these are known as isomers, and this property is known as isomerism. Due to such property of isomerism. They are very chemically diverse in nature. Okay, the next property is uh, the next reason due to which they are very large, they exist in very large number, is multiple bond. Carbon has the ability to make single, double, or triple covalent bonds to itself as well as to other atoms like oxygen, nitrogen, etc. For example, carbon can form single bond, double bond, and triple bond to itself as well as with another atoms like nitrogen, oxygen, sulfur, etc. So that's why there exist very large number of organic compounds due to the third reason, called multiple bonds. Carbon can form multiple bonds with itself as well as with other atoms. Okay, general characteristic of organic compounds. There are few characteristics. The first one is occurrence. Most of them come from living things or from the things that were once living, like the fossil fuels, the dinosaurs, etc., or the petroleum, hydrocarbons, diesel, etc., crude oil, natural gas. The second one is covalent nature. Basically, they are generally covalent in nature. They may have polar or non-polar bonds. There exist covalent bond in the compounds, in organic compounds. Such covalent compound may be polar or non-polar. We have discussed polar and non-polar covalent bonds in 9th class in detail. The third one is composition. As we have studied in the definition, that carbon is the main constituent of organic compounds. Hydrogen is also frequently present in organic compounds. Oxygen, nitrogen, and other atoms can also be present in organic compounds. So basic composition of organic compounds is the presence of carbon and hydrogen. And some organic compounds may also have oxygen, nitrogen, etc. Like this huge organic compound molecule, where where each corner shows carbon and hydrogen, and it also contains nitrogen, oxygen, etc. The next one is melting and boiling point of organic compounds. They are basically volatile. They have low melting and boiling point. Let's say petrol is organic compound. They're volatile. If you left petrol in open container, it will evaporate without heating within few minutes or few hours. So they have very less melting and boiling point. The next general characteristic of organic compound is that of solubility. We have discussed in detail in 9th class that polar compounds will dissolve in polar solvents and non-polar compounds will dissolve in non-polar. So polar organic compounds are soluble in polar solvents and non-polar organic compounds are soluble in non-polar solvents. For example, this is organic compound known as ethanol. This OH forms hydrogen bond with water. So ethanol is polar compound and water is also polar solvent. So both these dissolve in each other. Similarly, some organic compounds that are non-polar like benzene will dissolve in non-polar solvents like CCl4, etc. The next one is homology, most important characteristic of organic compounds. Series of related compounds in which any two adjacent molecules differ by CH2 group is called homologous series. For example, this is a series of organic compounds from 1 carbon atom to 10 carbon atoms. These two uh, molecules differ by only CH2 group. Like here there is 1 carbon atom and here there are 2 carbon atoms. So difference is 1 carbon atom. Similarly, there are 4 hydrogen atoms and here there are 6 hydrogen atoms. So difference is 2 hydrogen atoms. So the difference between CH4 and CH3 is CH2, 1 carbon and 2 hydrogen atoms. Similarly, the difference between CH3 ethane and CH3 propane is only CH2. Similarly, the difference between propane and butane is only CH2 group. So such a series in which two adjacent molecules differ only by CH2 group, by common CH2 group, is known as homologous series, and this property is known as homology. For example, heptane and octane differ from each other by only CH2 group. Such series of organic compounds is known as homologous series, and this property is known as homology. You have to learn, you have to remember, you have to learn by heart the name of all these compounds: methane, ethane, propane, along with their structural formulas. The last one is reaction rates. Organic compounds are generally less stable than inorganic compounds. Due to covalent bonding in them, their reaction rates are often slow. Like, let's say in daily life example, oil is an organic compound, meat or protein is also an organic compound, so these react with very low rate. They react very slowly, and also by gaining heat, we supply heat for this reaction to occur. Whereas inorganic compounds like salt and water, they react very frequently, and the reaction rates are very fast. So the reaction rates of organic compounds are generally very slow. Okay, Allah Hafiz. Thank you so much. Remember me in your prayers.